Welcome back. We're writing Little Man Computer in C++, and last time we'd just got to the beginnings of splitting our string, or each string of our assembly language program, into the individual tokens for the label, the opcode, and the address. And we got to the point where it worked with a single space between, if we have a look, a single space between each part of the string. But what we're going to want to happen is to be able to extend that to cater for multiple spaces. And I had a bit of a dig around on the internet, and I discovered that you can do it relatively simply with regular expression, something along these lines, which we'll have a little bit of a play with today, I think. The first thing we're going to need, though, to be able to do that is a test that fails with multiple spaces between things. So if we get our tests out like so, we can find where we got to. So we have this instruction. So if we create a new test by copying this that has all of the component parts, load instruction with oh dear, I didn't mean to do that, with label and address with multiple spaces between, and then we can do something like this, like so, and we'll end up with this, and this should fail quite straightforwardly. And then we can have a little bit of a dig around and see if we can make our test pass by changing our split to use a regular expression instead of our current standard split operator function. So if we go in here, we're currently creating a vector of tokens and then doing this stuff with creating a string stream and iterating through it with a single space as our delimiter. So if we just delete that and have a look at what we're doing here. So here we're creating a regular expression as the separator, and I believe that regular expression is just the separator rather than being the whole thing that we want to capture. So if we create such a regular expression, is it just regex? Yep. And that's going to be something along the lines of this. I do not know what the escaping requirements are here, so we'll give that a go for a start and see where that gets us. So that's our regular expression. I'm not sure whether that is a top field or whether that's a constructor, so we'll come back to that as well in a moment. In fact, perhaps we'll just see if that compiles for now, and then we'll come back to dealing with it. We have an unused parameter as the only problem, so I can live with that for now. If we also look and see what it's doing, it's then using this sregex token iterator, which takes yeah, I'm not entirely sure what they're doing here with these component parts, but we'll find out in a second. Let's just unabashedly copy what's going on here and see what the behavior of that is. And we'll kind of find our way around from there. So that's sregex token iterator. Like so, and they've split it into first and last now. I don't know whether they're just trying to split into two parts. That doesn't look like what they're trying to do. So let us see what happens if we just do that. So they've created a first like so, with begin, end, separator, and -1, and then this thing called last, and we can just do away with our tokens for the time being, like so. So that looks, I think, like what they're doing in here. Let us see what the behavior of that is. If that's, I haven't included the token iterator. We'll see if that's an issue. It doesn't appear to be. That may well be part of the regex include that we've already added. So if that compiles, and we're on the tests. Oh, indeed, that just works. That's very nice. Good. What I will do, so we can delete that. So that passes as is, which is kind of nice. Let me just run that again after deleting that line. It shouldn't make any difference whatsoever. But I just wanted to double check that I hadn't misremembered all of the tests passing. That's certainly looking promising. Good. So that looks acceptable. What I'd like to do is just write a test. No, I don't really need to. I was going to say write a test with multiple spaces at the beginning, but we already have a test with spaces at the beginning there. I wonder if we want to allow tabs as well here. I think we probably do. So let us replicate this test, but this time have a tab separation. With tabs, or tab. Let's call it tabs, and see what we get here. And that should fail for us nicely. Did I write that? Yes. And I would expect that to just fail, as we're only... Oh no! \s in the regex will catch tabs as well, which is good. So in which case I'm going to leave that test in, just in case, as it shows the behavior nicely. So how are we now? We have this structure, which I think is fine for the split. We're splitting basically on any white space. It's perfectly happy with leading and trailing white space values. So I don't think we actually need to do anything special for that now. I wonder if now I can put this back, because it was a little bit weird that didn't work. It's possible that it still doesn't work, but yeah, I do not know what that's about. That is a little strange. Something going on in the all of that is broken by including stream, but we don't need stream anymore. So maybe that's fine, because we're not using string stream to do anything. So what if we now do the compile? No, that still doesn't like it. That's fascinating. Answers on a postcard. So we'll put that back to where we were. Have a quick think and see if there's any reason why that wouldn't work, but I cannot think of any reason why. No. It's very strange. That's so we've deleted string stream, hestream. That should be fine for now. We may want to put that back in, or in some form when we go to the next stage of iterating over things. Now the question is, do we want to, at this stage where we're dealing with things like this, deal with comments, or do we want to not? I kind of get the feeling that that's something we might want to deal with here. It's possible, actually, looking at this, that trailing comments in this already work. Let us do that. And it might be that we only need to ignore what do we want to do with this? We might want to only ignore comment only lines. So if I take this as is, and with trailing comment is correctly parsed, we should be able to find that is that the right comment formulation? That seems to be what they're using in here. So we should find that just works. Because we're only taking the first 3 tokens there. And it should be fine also. No, that isn't going to quite work, is it? Because, so that's going to work, but if we have no address, then it won't work. Which is fine. So maybe we can deal with that with an initial split on the comment character string. So let's try that. Load instruction with no address and trailing comment. So that version should be this, but I have a feeling it's not going to be. I have a feeling it's going to be the 2 forward slashes and fail the test, which would be nice. And in which case we probably want to do an initial split on, yes, that's fine. Also, we probably want to do an initial split on the double forward slash. So I think the easiest way to do this is to have a const string regular expression string here. So if we start by refactoring this, so that should still just fail the 1 test, but we're now able to have an alternative split string or a regular expression of 2 forward slashes. Which would be very nice. Yep, that seems okay. So we can first code and comment equals split instruction string. The question is, does that need escaping or not? We don't know. And then that should be code and comment 0. No, we're still not dealing in any way with exceptional cases at the moment, which we may or may not get to at some point in the future. For now, we just want the happy path to be tidied away. So I'm expecting this to pass in all cases, and it does. That's excellent. So what are we doing here? We are splitting into code and comment, and we are then taking the tokens for that, and I guess we can then use this to loop through all of the lines of the input and filter out anywhere the instruction parts are all the empty string. I imagine. I don't know what we would do in the case where we have a label and no. I mean, we're looking at exceptional cases now, so we've gone slightly off topic. But if we have a label and no opcode, then I would imagine that's an error, which is fine. Good. So that's, I think, all of the cases for parse instruction that we want to handle at the moment. I can't think of any other failing tests. No. So let's check that in. Git being very slow today. Seems to have found itself again. So, how are we naming things? Commit parse instructions with multiple white space and trailing comments. White space and trailing comments. That should be fine, and we'll move on to iterating over multiple lines next time.